Sufficiency City, Baltimore's strategy for new nature in 2100. The Sufficiency City new nature design for Baltimore's lower middle branch is inspired by the most extreme projected climate change conditions that result from the highest greenhouse gas emissions in the year 2100. By 2100, temperatures are projected to increase by 11.5 degrees, resulting in a shift in agricultural hardiness zones, increased hypoxic or dead zones on the Chesapeake Bay, and degraded air quality to dangerous levels. According to the EPA's 2019 survey, 52% of U.S. counties experienced air pollution levels considered to be moderate to extreme, even with pollution-restricting policies from the Clean Air Act. These issues are exacerbated as temperatures increase. The NOAA reports a positive correlation between summer maximum temperatures and the number of stagnant days. This temperature increase allows pollutants to react and cause health concerns, including decreased lung function and developmental issues in children. Worst-case scenario trajectories made by the U.S. Climate Change Science Program and NOAA estimate that sea level will rise by 8.2 feet by 2100, and ultimately by 11 feet, putting large portions of Baltimore's networks underwater. Baltimore's heavy reliance on non-renewable energies and fragile imported food systems create a need for new technology implementations to move it towards a self-sufficient city. Our team of 4 investigated the vital aspects to consider when creating a prototype for a self-sufficient city in 2100. A new nature, community needs, food production, and energy production. Each team member explored in depth one of these topics in search of revolutionary ideas to address the inclement need to sustain populations and design for an uncertain climatic future in the lower middle branch of Baltimore. In this apocalyptic but possible future, city populations have relocated upland to heavily controlled dome communities in less polluted areas to allow for the waterfront to adapt to a new nature ecosystem consisting of species tolerant of harsh climatic conditions and pollution. As sensitive wetland environments regenerate in the middle branch, southern tidal grass species become the new native. These plants, along with hardy catfish, become part of the new bay ecosystem. Outside of the domes, each island is allowed to regenerate vegetal growth with no human intervention. As hardiness zones shift and Baltimore's ecosystem becomes more like that of the Gulf Coast of Texas, new tree species will fill the niches of trees that used to be hardy in Baltimore. Southern species like the loblolly pine, bald cypress, and southern magnolia make up the new native species found in this wood and in the regenerated areas on land. When new nature ecosystems have regenerated and pollutants have been remediated, there will be a potential for the natural world to be ventured into once again after significant growth, remediation, and time. A semi-visible barrier is erected to indicate a break between the regulated areas and the wilderness and protect community members from crumbling buildings and other pollution hazards. With brightly colored trees as posts and force field railings, the barrier only allows someone through if they have the proper credentials. Nearly invisible, the fence is barely there. Residential dome communities can be found near the barrier of the new nature. These communities focus on retaining the necessities of a healthy living space, such as transportation services and access. The circular structures create space for outdoor recreational landscapes confined within the community. These areas may only be accessed on days of low exposure risk. The outdoor spaces defined by these structural forms are home to trails, water features, and recreational facilities. Inside the structure, walkways, bike lanes, and autonomous public transportation create public space when extreme conditions demand indoor isolation. In places like Austin, Texas, ordinances require 50% of construction and demolition materials to be diverted from landfills. With roughly 16,000 vacancies in Baltimore, the opportunity to experiment with and reuse materials is abundant. While some nonprofit organizations in Baltimore already recover and recycle materials, it is recognized as a difficult task due to the abundance of blight and price of deconstruction over demolition. Throughout the next century, however, pressing climate issues will require the experimentation of material development, which will include the use of recycled materials. In addition to the dome communities, stationary islands aim to take advantage of increased water surface area, protect residents from environmental health hazards, and harvest energy and food locally. Climate change is expected to shift hardiness zones significantly. Areas surrounding agriculture domes will experiment with agricultural practices for shifted hardiness zones. The domes regulate climate within a solar-generating and air-filtering outer shell to create ideal growing conditions for maximum calorie nutrient-rich crops. Food is grown in a controlled environment that eliminates any risk for crop devastation as a result of climate change disasters. Restaurant domes are available for communities to gather and eat within a welcoming yet productive landscape. The restaurant dome utilizes aeroaquaponics to create a self-sufficient dining system. Abundant vertical space is utilized, creating two inviting eating areas. Using a combination of aeroponics and aquaponics, the system is estimated to be 390 times more efficient than traditional farming. Aeroaquaponics agriculture produces maximum calorie and nutrient-rich crops that are calculated to satisfy daily human nutritional needs. Elements of this agricultural technology, such as aeroponics, aquaponics, and vertical growing systems, are seeing increased yields and resource efficiencies in comparison to traditional agriculture. Our design takes inspiration from these developing technologies, anticipates their projected progress, and applies them on a larger scale to address the growing challenge of food security at a local scale, both above ground and underground. In this system, water from the bay is treated and incorporated into the aquaponics system. Nutrients from the fish farm get pumped through the agriculture levels and sprayed onto the plant roots to support bio-intensive farming that can feed and sustain surrounding neighborhoods. Surrounding islands utilize solar and wind harvesting technologies to generate energy for city residents. Untouched by humans, the Sufficiency City's energy islands are multifunctional, serving as wildlife habitat and harnessing renewable energy. The energy islands consist of bladeless wind turbines and solar coverings that protect understory pollinator habitat. Based on efficiency technological projections, renewable energy harnessed on the 6 energy islands generates considerable power, enough for all activity in Baltimore. The highly efficient bladeless wind turbines generate the bulk of power. While our goal is to create a design that is unique to the Baltimore area, this heavily controlled prototype is designed to protect humans from harsh elements, including conditions on other planets, where efficiency, control, and protection are needed. Ideas from our 2100 vision could be applied at a variety of scales and implemented in phases. Without intervention, this apocalyptic world could become our reality. Based on trends reported by the National Oceanic and Atmospheric Administration and Environmental Protection Agency, the climate is changing much faster than has been predicted in the past. Unpredictable climate conditions have already impacted the vital systems needed to support our societies and current lifestyles. Environments that we are familiar with now will not be the reality of our future. Our idea of new nature may change the way designers choose materials and species. Designing for future climates and scenarios may be more important than the issues that designers currently seek to address, such as using native species and preserving ecosystems. Throughout our research, we discovered few sources that can confidently predict the future of our ecosystems. This lack of information makes it difficult for designers to find reliable sources and confidently design for our futures. Delayed efforts to mitigate the changes we are seeing could result in catastrophic consequences that require drastic and controlled measures to sustain human life. As Greta Thunberg said, "I want you to act as if the house is on fire, because it is."